Hello, hello, hello everybody, and welcome back to more of the 2007 Fermat paper. Root Beer here, and we're looking at question 21, the very first question in part C. 5 consecutive positive integers have the property that the sum of the second, third, and fourth is a perfect square, so the middle three numbers add up to a perfect square, and the sum of all 5 is a perfect cube. Ooh, interesting. If m is the third of these 5 integers, so the middle one, okay, then the minimum possible value of m satisfies, and then we have a whole bunch of ranges. M is less than or equal to 200, between 200 and 400, 400 to 600, okay. So they give me the middle number m. It makes sense to start talking about these 5 consecutive positive integers all in terms of m. Okay, so if the middle one is m, the next one's m plus 1, and then the largest is going to be m plus 2. The one before m is m minus 1, and the smallest is going to be m minus 2. Okay? Because they told us that these are consecutive positive integers. Now, we know the sum of the second, third, and fourth is a perfect square, and the one's going to cancel out. We're just going to be left with 3m, and that's going to be a perfect square. And the sum of all of them, m minus 2 plus m minus 1 plus m plus 1. So it's very nice that we have the middle one named because all the constants are going to cancel out, and the sum of all of them is just 5m. And we know that that's a perfect cube. Call it n cubed. Okay. Well, what can we do now? What can we do? Well, 3 and 5 are both primes. So if 3m is equal to k squared, that tells me 3 divides k squared. But that's k times k. And if you have a prime, if you have any prime, and it divides a product, whatever the product is, then the prime divides at least one of the two factors. So 3 either divides k or 3 divides k. And from there I can conclude, of course, 3 divides k. So we could say something like, let k be 3s. I don't know why I wrote u. We'll say s. But then 3m is going to be 3s squared, which is 9s squared. So m looks like 3s squared. So m is 3 times a perfect square. Okay. What else can we figure out? Well, we know 5m is n cubed. So that means 5 divides n cubed. And it's not that hard to see from there that 5 divides either n or 5 divides n squared, and then just like before, ultimately we can conclude 5 must divide n. So we could say something like n is 5t. And now 5m is 5t cubed. It's going to be 125 times t cubed. And so from there, m is 25 times t cubed. Okay. But now I know 3s squared is the same as 25 t cubed. Okay, they're both expressions for m. And we can do the same sort of thing. I know 3 has to divide 25 times t cubed. So 3 is going to have to divide t. We'll move over to the next page to deal with some of this. So 3s squared is 5t cubed. So 25t squared, I should say. So 3 divides 25 times t cubed. So either 3 divides 25 or 3 divides t cubed. But 3 can't divide 25. We know that that's not true. So 3 divides t cubed, and that tells me 3 divides t. So, I don't know, let's let t be 3u. So now I have 3s squared is 25 3u all cubed. we could say that's 25, and then times 27 u cubed, divide by 3 on both sides. I know at least s squared now is 25 times 9 times u cubed. Okay. Well, if I want m to be as small as possible, I want 3s squared, which is m, to be as small as possible. So I'd like s squared to be as small as possible. Now, I can note right away that 25 times 9 is just 5 times 3, or 15, squared. If I'd like s to be as small as possible, let's let u be 1. Okay. Then s is going to be 15. Now, we should make sure to check, can we get a t value that makes sense? Okay? Because, maybe this works for s is 15, but really s is 30 is the one we need to make t cubed be an actual integer. So we'll just check. Let's check on a value of t. So 3 times 15 squared is going to be 3 times 5 squared times 3 squared, which is going to be 3 cubed times 5 squared, which is 25 times 3 cubed. So in this case, t would be 3. Okay, well that at least works out. Okay, so m is 3 times 15 squared, so that'd be 3 times 225, and that'll be 675. So that's the smallest that we can get. Okay, we can get other ones. Different u values will give us different m values. But if we want it to be as small as possible, we make u as small as possible, and so it's going to be 1. So the smallest m can be is 675, and that is in which range? That's right here, it's D. Bigger than 600, but less than or equal to 800, 675. Okay, and that wraps up question number 21. Feel free to join me in the next video for question number 22 as we continue our look at the Fermat paper.